The United States of America possesses the largest railway network in the world. Nearly 225,000 kilometers of steel tracks piercing the continent, from the freezing winds of Maine to the sunny beaches of California. That's more than in China, Russia, or India. You would think that with such scale, trains should be the primary mode of transportation for every American. We watch Hollywood movies where characters cross the country in luxurious dining cars or speed by on futuristic expresses. But if you visit the US today and try to take a train, say from Chicago to Los Angeles, you will face a reality that would shock any European or Asian tourist. The train might be late by 10, 15, or sometimes even 24 hours. It will travel slower than a car on the highway. And high-speed rail, like Japan's Shinkansen or France's TGV, is virtually non-existent here. Welcome to the great paradox of American railroads. The country that was literally built by trains today prefers to fly over them or drive alongside them on the asphalt. But does this mean U.S. railroads are dying? Absolutely not. In fact, they are experiencing their golden age and generating billions of dollars in profit. They just don't carry people. They carry America. About 40% of all the nation's freight moves by rail. This is the circulatory system of the world's #1 economy, hidden from the eyes of the average tourist. In this video, we'll take apart U.S. railroads piece by piece. We'll find out why passenger trains are always late, how the monstrous locomotives pulling 3-mile-long trains work, what precision scheduled railroading is, and why unions hate it, and why private corporations hold power comparable to the government itself. Get comfortable. We are departing. To understand how modern trains operate in America, we need to start with that very paradox. Why did a great railway nation switch to cars? In the late 19th and early 20th centuries, railroads were kings. Private companies built luxurious stations and competed fiercely for speed and comfort. But after World War II, everything changed. In 1956, President Dwight Eisenhower signed the bill creating the Interstate Highway System. The government poured colossal amounts of money, billions of dollars, into building perfect, smooth, toll-free roads. Simultaneously, the state began subsidizing airports and airlines. While roads in the sky essentially became free infrastructure for cars and planes, railroad companies had to keep maintaining their own tracks, pay massive property taxes on the land beneath them, and suffer heavy losses from passenger routes that were rapidly emptying out. By the 1970s, U.S. railroad giants were on the brink of mass bankruptcy. Passenger service became a financial anchor, dragging them down. To save the industry, the government made a deal in 1971. It created Amtrak, a quasi-public corporation that took over all the unprofitable passenger routes. In return, the private freight companies, like Union Pacific or BNSF, got the right to focus exclusively on cargo. But there was one crucial condition. Freight companies were required by law to give Amtrak trains priority on their tracks. While passenger rail in the U.S. is a frequent target for criticism, its freight network is the envy of the world. American freight railroads are the most efficient, profitable, and technologically advanced transportation machines on the planet. They move about 40% of all long-haul freight in the country. Without them, Walmart shelves would empty in a couple of days, power plants would run out of coal, and farmers wouldn't be able to sell their grain. The market is controlled by so-called Class I railroads. After a series of mergers and acquisitions, a few mega corporations rule the U.S. today. West of the Mississippi River, Union Pacific and Warren Buffett's BNSF dominate. In the east, it's CSX and Norfolk Southern. In essence, these are regional monopolies. In the 1970s, engineers came up with a brilliant idea. Instead of putting a single shipping container on a flat car, they designed cars with a lowered center, known as well cars. The container sits right down between the wheel bogies, almost touching the rails, and a second one is stacked right on top. This doubled the train's capacity without increasing its length. You can't pull this off in Europe. The bridges and tunnels are too low, and there are overhead electric wires. American tracks are mostly unelectrified, and bridges on the main lines were specifically rebuilt over the years just to clear these two-story mountains of steel. The efficiency is staggering. A modern freight train in the US can move 1 ton of freight nearly 500 miles on a single gallon of diesel fuel. That is 3 to 4 times more efficient than highway trucks. But what pulls these endless strings of cars? Meet the American locomotive. Almost all freight main lines in the US are unelectrified. Building and maintaining overhead wires across tens of thousands of miles through the Nevada deserts or Montana mountains is too expensive and pointless for freight companies. Therefore, the diesel carry their own power plants. A modern American locomotive is a diesel-electric machine. Strictly speaking, the diesel engine does not turn the wheels. Its only job is to generate electricity. Let's look inside the monster. For example, the ultra-popular GE Evolution series. Its heart is a massive 12-cylinder, 4-stroke diesel engine the size of a minivan, pumping out a crazy 4,400 horsepower. This engine is connected to the main generator. The diesel burns fuel, spins the generator, and produces high-power alternating current. Next, the electricity passes through a complex system of rectifiers and inverters that convert it exactly as needed for traction control, and only then is this current fed into the electric traction motors. They are located down below on the bogies, directly on the wheel axles. Each locomotive usually has 6 axles, and each has its own electric motor. Why such a complicated setup? Why doesn't the diesel turn the wheels directly through a gearbox, like in a car? It's all about torque. An electric motor, unlike an internal combustion engine, delivers maximum torque right from the start at 0 RPM. And to get a 20,000-ton train moving, you need incredible starting force. If there were a mechanical gearbox, it would simply be torn to pieces by the strain. But one locomotive is not enough for a modern train. You'll often see 2, 3, or 4 units up front. However, if the train is extremely long, a physics problem arises. If all the pulling power is at the front, the massive weight of the rear cars can literally push parts of the train off the tracks during braking or on curves. That's why Americans massively utilize DPU, distributed power units. Radio-controlled locomotives are placed in the middle and at the very end of the train. The engineer sits only in the lead locomotive. The onboard computer uses a radio link to control all the other locomotives in the train. If the lead unit applies power, the rear unit also applies power, pushing the train from behind. This allows them to build trains of unimaginable length, up to 3 miles long. Over the last 10 to 15 years, U.S. railroads have undergone a radical management revolution that brought billions to Wall Street but sparked fury among workers. This system is called PSR, Precision Scheduled Railroading. Sounds like a good thing, right? But in reality, for freight companies, it meant the ruthless optimization of absolutely everything. The architect of this system, the late Hunter Harrison, changed the very philosophy of the business. Previously, trains departed only when enough cars of a specific type were assembled. In the PSR era, trains started running on strict schedules, regardless of the type of cars. Companies started mixing everything together: containers, chemical tank cars, coal cars, all into one giant train. The primary goal of PSR is to lower the operating ratio, meaning to spend as few cents as possible for every dollar earned. And companies started slashing costs. They closed dozens of classification yards. They cut nearly a third of their entire workforce: mechanics, inspectors, engineers. Those who remained were forced to work grueling schedules, often without proper sleep. And most importantly, trains simply became enormous. Trains 2 or 3 miles long became the norm. The logic is simple. Why pay 2 crews for 2 trains when you can link them into one megatrain and pay just 1 crew? But physics has limits. Inspectors in the yards are now given only 1 or 2 minutes to inspect each car. Giant trains put colossal stress on the tracks, and it is because of this extreme cost-cutting that safety issues began to surface. A glaring and tragic example was the derailment in East Palestine, Ohio in February 2023. A Norfolk Southern train carrying toxic chemicals derailed due to an overheated wheel bearing. Trackside temperature sensors triggered too late. The town is still dealing with the fallout of that environmental disaster. Unions are shouting in unison. This is the result of PSR, workforce cuts, and skimping on safety. The railroads are bringing in record profits, but the infrastructure is being run into the ground. Despite the challenges, U.S. railroads are an incredibly complex technological mechanism. How do you manage thousands of trains moving toward each other on single-track lines? In the past, safety depended on the engineer's eyes and trackside signals. Today, the show is run by PTC, Positive Train Control. It's essentially a safety autopilot mandated by the U.S. Congress after a series of deadly collisions. PTC is a massive network of GPS sensors, trackside communication towers, and onboard computers. The system knows the exact location, speed, weight, and track profile ahead for every train in real time. If a train approaches a red signal, a work zone, or a sharp curve too fast, the onboard computer first warns the engineer. If the engineer doesn't react within a few seconds, for example if they have a medical emergency or fall asleep, the PTC system takes over and automatically applies the emergency brakes. It will physically prevent the train from running a red light. Implementing this system cost the companies billions of dollars, but it has virtually eliminated accidents caused by human error. But what about the passengers? Is there a light at the end of the tunnel for everyday Americans who don't want to fly? Yes, and that light is coming not from the government, but from private business. Look at Florida. This is where Brightline operates. It is the first private passenger rail company in the U.S. in a century to build its own stations and tracks. Brightline connected Miami and Orlando with comfortable, fast trains. It's not a classic bullet train. Its top speed is about 125 miles per hour. But it's clean, it arrives exactly on time, there's fast Wi-Fi in the cars, and the service feels like a good airline. Brightline's success in Florida inspired the company to start building a true high-speed line, Brightline West, which will connect Los Angeles to Las Vegas. Trains there will reach speeds of nearly 200 miles per hour, and the line is expected to open in time for the 2028 Olympics. American railroads are a world of contrasts. It's the aging Amtrak passenger cars sitting for hours on a siding, and at the same time, it's the most powerful, technologically advanced, and efficient freight network in the world, digesting millions of tons of goods every single day. The paradox hasn't gone anywhere. Americans still love their cars and planes, but every time a New Yorker buys fresh fruit from California, every time gas arrives at the station and metal at the factory, they should thank those invisible steel giants that day and night, through rain and snow, carry the economy of the United States on their shoulders. Perhaps the golden era of passenger trains in America was left behind in black and white movies, but the railroads here are not dying. They have simply become a circulatory system that works so well we don't even notice it. Thank you for joining us on this long journey. Make sure to subscribe to the channel and leave your thoughts in the comments. Do you think America needs to build high-speed rail, or does the future still belong to airplanes? See you in the next episodes.